Hi, this is John Isles and welcome to Geometer's Paradise. Today we're going to be talking about the Chapter 5 review for parallel lines. I'm going to kind of go over everything here, even though some things will be on the final unit test and other things won't. So here we go. The first thing we want to talk about is parallel or skew. When we have a box like this one, parallel lines are lines that go in the same direction and don't intersect. Skew lines are lines that go in different directions and don't intersect. So for example, line AB here goes left to right, so does FG, so does ED. All of these lines are parallel. AB is parallel to FG, for example. Or BG is parallel to CD. Or AF is parallel to BG. Skew lines are lines that go in different directions but don't intersect. For example, AB and GD. AB goes left to right in the back. GD goes up and down in the front. That makes AB skew to GD. That's two words there. Okay. All right. The theorems themselves. Not going to spend any time here. Just remember that the parallel transversal theorems, the PTTs, okay, are parallel lines that end up being with angles being congruent. Parallel, congruent. Parallel, congruent. Parallel, supplementary. All right. While the converse parallel transversal theorems, the CPTTs, all right, they are congruent to be parallel, congruent to be parallel, congruent to be parallel, and supplementary to be parallel. Okay, let's fix that. All right, so the one is parallel to congruent, the other is congruent to parallel. All right, on the final unit test, the angle hunt probably isn't going to be on it, but it is on the mid-test, the mid-chapter test. It's fairly easy though. We're just taking angle 4 here to be 58 degrees, and then we're going to proceed through the angles. 1 to 8, 8 to 6, 6 to 3, 3 to 5, 5 to 7, 7 to 2. So we're just going one to the other just like this, starting with 58 to angle 1. Well, 58 to angle 1 is a vertical angles theorem, and so they're congruent. So 58 by the vertical angles theorem. And then we're going to go angle 1 to angle 8. 1 to 8 is alternate exterior, so this is also 58. AEAT. Then we go 8 to 6, that's a linear pair, so this is 122, 180 minus 58, linear pair theorem. And then we're going to go 6 to 3, that's an alternate interior connection, so 3 is 122, whoops. AIAT. And then angle 3 to angle 5 is consecutive interior, so angle 5 is 58, 180 minus 122, so we're back to 58, consecutive interior angles theorem. And then angle 5 to angle 7, that's 122 again by LPT. And then angle 7 goes to angle 2, so that's going to be 122 alternate exterior. All right, remember it's the big curve. Okay, just a couple of words here. Remember that if we cross one line on our way, it's straight and crosses one line. This is a corresponding angles relationship. If we go straight from one to the other and cross no lines, that's a consecutive interior angles relationship. If we have a curvy line and we cross over the transversal just the one time, this is AIA. But if we have a curvy line that crosses over 3 once, twice, 3 times, this is AEA. Okay, so that's the key. That's how you tell the difference, drawing the lines. We aren't going to do the calculations on the second test. We do calculations on the mid-chapter test, but not the end of unit test. That said, though, this is a corresponding angles relationship, which means that we would set 3x plus 10 equal to 7x minus 6 by the corresponding angles theorem. And then we would solve for x. This contrasts to this problem where we have a CIAT relationship. So that means that 5x plus 10x plus 30, that's a plus right there, except it looks like an and, is equal to 180 because of the consecutive interior angles theorem. So that was the big difference in calculations. All right, so now we're going to talk about using the parallel transversal theorems. This is the kind of proof that you're going to get on the test. All right, you're going to get one of these, and the difference between this proof and the ones that we've been studying this last week are that this proof, this was the first couple weeks, we have A parallel to B and T parallel to S as our given, and we're showing congruence. This is in contrast to the most recent ones where we have congruence and parallel to show parallel. So A parallel to B connects 9 to 16 by the alternate exterior angles theorem, and T parallel to S connects 1 to 9 by the corresponding angles theorem. Angle 1 is congruent to angle 9. CAT, because T is parallel to S. Angle 9 is congruent to angle 16. AEAT, because A is parallel to B. Then angle 1 is congruent to angle 16, transitive property. Okay. This is a consecutive interior angles proof. Same idea though, we've got A parallel to B and T parallel to S, so we will connect here. This is a corresponding angles relationship from T to S, and then 11 to 13 is CIA from A to B. So angle 5 is congruent to angle 13, corresponding angles theorem because T is parallel to S. Angle 11 plus angle 13 is equal to 180. This is consecutive interior. Remember, consecutive interior angles are supplementary. This is because A is parallel to B. And then we do a substitution here. We're going to take 5 and we're going to substitute it into 13. Angle 11 plus angle 5 is equal to 180 by substitution, and that takes care of our proof. The only difference is that we're adding up equal to 180, and CIA is the key to making that happen. Okay, now we're going to prove the parallel transversal theorems. All right, this is a proof of the alternate exterior angles theorem. Our goal is to get angle 1 congruent to angle 8 while limiting ourselves to only using the CAT theorem, the VAT theorem, and possibly the linear pair theorem. We don't usually use that though. This is only for consecutive interior angles. All right, so the key is to connect 1 to 8 using vertical and corresponding angles. So we can either go 1 to 4 vertical angles, 4 to 8 corresponding angles, or we could go 8 to 5 vertical angles, 5 to 1 corresponding angles. It doesn't matter which route you choose. All right, so angle 1 is congruent to angle 4, vertical angles theorem. Angle 4 is congruent to angle 8, corresponding angles theorem. Angle 1 is congruent to angle 8, transitive property. That's that. Okay, this proof is definitely on the test. This is one of my personal favorites. It starts with these three angles being a straight angle. There we are. So straight angle. That means that angle 4 plus angle 2 plus angle 5 is equal to 180. This is actually a combination of the straight angle theorem, which says that a straight angle measures 180 degrees, and also the angle addition postulate, which says that if we add angles up, they are going to be equal to the whole. It's actually a combo, straight angles and angle addition, but if you just say straight angles, I'm cool with that. Now I want to connect 4 to 1. That's an alternate interior relationship. So angle 4 is congruent to angle 1, AIAT. And then angle 5 is congruent to angle 3, AIAT. And that means that angle 1 plus angle 2 plus angle 3 is equal to 180 by substitution. This is a biggie. I'm testing you on this 3 times, okay? End of Unit 5, the first quiz in Unit 6, and then the Unit 6 test. Okay, now we're talking about the converse theorems. Remember that the regular theorems, all right, the regular version is parallel to congruence, or in the case of consecutive interior angles, supplementary. The converse theorem reverses that direction and goes, well, that totally failed. Change the color. The converse theorem reverses that direction and goes congruence and supplementary to parallel. So this is our first task, presented with the, presented with this drawing. If 4 is congruent to 5, which lines are parallel? Well, A is parallel to B because 4 is congruent to 5. And the theorem we use is the converse alternate interior angles theorem. Notice that we have a C now in front of the theorem name. 1 congruent to 9 is a cat. Okay, this is T is parallel to S. Converse corresponding angles theorem. We have 8 to 15. This is a CIA. A is, or I'm sorry, no, not A. T is parallel to S again. T to S. C, CIAT. And 9 to 16, that's an alternate exterior A to B. Okay, now let's write a couple proofs. This proof is different from the others because it's not a 3-step proof that ends with a transitive property. Instead, it's a 4-step proof that ends with a converse parallel theorem. There's a pattern to these. It's given, parallel transversal theorem, transitive property, converse parallel transversal theorem. So we start with angle 1 being congruent to angle 16. This is our given. Then T is parallel to S. So if T is parallel to S, then I say that 1 is congruent to 9. So angle 1 is congruent to angle 16. This is given. And then angle 1 is congruent to angle 9, corresponding angles theorem because T is parallel to S. Angle 9 then is congruent to angle 16 by the transitive property. See it here? 16 through 1 to 9. Now we come back to the drawing and we say, what relationship does 9 have to 16? Well, it's alternate exterior. So that means that A is parallel to B by the converse alternate exterior angles theorem. Let's do it again. This time 1 is congruent to 16, given, and now A is parallel to B. So instead of connecting 1 to 9, T to S, I'm going to connect 16 to 9, A to B. Angle 1 is congruent to angle 16, given. Angle 9 is congruent to angle 16, alternate interior angle theorem, because A is parallel to B. Then angle 1 is congruent to angle 9, transitive property. See, 1 to 9. So now I come back over here again and I say, okay, what relationship does 1 have to 9? Okay, that's alternate exterior again. So, whoops. So T is parallel to S by the converse alternate exterior angles theorem. All right, the last thing we have to do is prove the converse parallel transversal theorem. This is very similar to the proof of the regular theorem, only this time instead of cat, vat, and leaped, we can do a converse cat, okay, of vertical angles theorem or a linear pairs theorem, but we won't do this unless we're doing consecutive interior. These are the two we use. So to get angle 3 congruent to angle 6, all right, we start with that. So this is our starting condition. We want to get corresponding angles. So we start here, and then we go 3 to 2, or you could go 6 to 7, either one. 3 to 2 means that 2 and 6 correspond. 6 to 7 means 7 and 3 correspond. Angle 3 is congruent to angle 6, given. Angle 2 is congruent to angle 3, vertical angles theorem. So angle 2 is congruent to angle 6, transitive property. Now I use the corresponding congruent angles 2 and 6. I say A is parallel to B by the converse corresponding angles theorem. And that's all you need to know for the test tomorrow. There's only going to be 7 or 8 questions. So good luck.